Hi guys, welcome to the Algebra 2 K exponents review. Alright, so for the first 9, we're just gonna simplify. Alright, so we got x7 over 3y times 6y to the negative 5 over 4x cubed to the power of 2. Alright, so first thing right here is we have a power rule. Every term in this fraction has to get raised to the power of 2. So 6 squared. Oh, why is it so blurry? This is it. Let's do that again. So 6 has to get squared. Y to the negative 5 has to get squared. So this is a power rule. Remember, you multiply your exponents. Right, the 4 has to get squared. Same with the x cubed. Right, first fraction, let's just keep it the same. x7 over 3y times. Alright, so when I square the 6, we get 36. Y negative 5 squared, so negative 5 times 2 makes y to the negative 10. And then 4 squared makes 16. And then x cubed squared makes x to the 6. Alright, so let's try simplifying this. Alright, so we have 36 over 16. Let's see what we can reduce that with. Alright, so again, you could always use your calculator to reduce 36 to 16. You get 9 over 4. So 9 over 4. Alright, also, so after we do this, we have 9 on top, but then we have a 3 and a 4. This 9 and this 3 just reduced to 3 over 1. Alright, so this is a 3 now. Alright, so up to this point, I have, so let me just rewrite what we have. We have 3 on top, x to the 7, y to the negative 10, over 4 to the x6, and y. Alright, so this is just off the 36, 16, and 3. This is what we have left over. Alright, so 3 over 4. Alright, we have 7 x's on top, 6 x's on the bottom. 6 of those x's are going to cancel 6 of the ones on the top, so we're going to be left with 1x. Alright, y to the negative 10 over y to the 1. So these 10 y's have to come down to the bottom, which gives us y to the 11. And again, you could also just expand everything. Here, if you do the quotient rule, this is what you would end up with. You would do 3 over 4. You would get x to the 1, y to the 11 from negative 10 minus 1. And then you would have to end up bringing this one down either way. Alright, so now let's look at 2. Alright, this one's to the power of 0, so this is just 1. Alright, so this is the one we're worried about. So this 5x over 2y squared to the power of negative 3, this fraction on the inside, if I were to flip it, it's going to make this exponent positive. So this is actually 2y squared over 5x to the power of 3. Alright, so this became positive because I flipped the fraction on the inside. And again, this is just 1. 1 times that doesn't affect anything. Alright, so then everything in here has to get cubed. Alright, 2 cubed. We got y squared cubed, so you multiply your exponents. 5 cubed. Here, let's write it 5 cubed. And then x cubed. Alright, so this is what we get when we cube this. We get 8 over 125, 8 y to the 6 over 125 x cubed. That's our answer. Then for number 3, here. So there's multiple ways you could approach this. You can either just go ahead and move this all to the top to make this positive 2, or you could just do the power rule, multiply this by negative 2. Here for this one, I'll do the power rule. So we have x to the negative 6, y to the 3 on top. Alright, if I do the power rule to this, x to the 4 to the negative 2 gives us 8 to the negative 8. Y to the power of negative 2 is just y to the negative 2. Again, you don't want any negative exponents, so let's see what happens. If I make these all positive, we have to switch the x's. We have y to the 8, y cubed, y squared, and then x to the 6. Alright, so x to the 6 had to move down, x to the negative 8 had to move up, y to the negative 2 had to move up. Alright, so y cubed times y squared, that's going to make y 5. X to the 8 over x to the 6. We have 8 x's on top, 6 on the bottom, so 6 of those. Cut 6 of these, which gives you 2. So we end up with x squared y to the 5. Right, now for number 4. Right, we have this negative exponent here, so I'm going to go ahead and just flip this so this becomes a positive 2. Alright, so now let's use the power rule. We're going to square every single term in here. So 5 squared, it gives us 25. Y squared squared, so multiply those, you get y to the 4. 2 squared gives you 4. X to the 5 squared gives you x to the 10. Same thing here. 5 squared gives you 25. Y to the 4 squared gives us y to the 8. Right, 4 squared gives us 16. And then x squared. Alright, so we're multiplying fractions, so just multiply across. 25 times 25. That's 625. We have y4 times y8. So when you multiply, you add your exponents. So this is y to the 12. On the bottom, we got 4 times 16. X10 times x squared gives us x12. And that's that one. Alright, now on 5, this is in radical form. Let's put it in exponential form so it's easier to solve. So we have 64 to the power of 1/2 to the power of 1/3. Alright, so 64 to the 1/2 to the power of 1/3. Another way you could write 64 is 8 squared. So this would be, here, let's just go ahead and multiply this. 1/2 times 1/3. That's 64 to the 1/6. Alright, there's two different approaches I could take here. So this is telling me the 6th root of 64, or I could just find something on my table of powers that has a power of 6 but gives me 64. So here, 2 to the power of 6 gives you 64. So I could substitute that in for 64. 2 to the 6, 1/6. 6's cancel, we just get 2. At the other approach here, this is the same as saying the 6th root of 64 to the power of 1. So remember, the denominator tells you the root, top gives you the exponent. So let's do math 5, or again math 5 Let's do power 6 of 64, and that's 2. So either approach works. All right, now for 6. We have 2x4 over 7y squared divided by 7y over 9x5 to the negative 2. Right, so this is a good one to know, good one to study. Right, the reason it's a good one to study is because there's 2 flips on here. So when you're dividing fractions, you do keep, change, flip. It's the same thing as multiplying by a reciprocal. Right, the first flip actually comes from this negative 2. We want to make it positive, so we have to flip this fraction. Alright, so right now we got 2x to the 4 over 7y squared divided by 9x5 7y squared. Alright, let's go ahead and square every single term in here. Alright, so when we square this, we get 81x to the 10, 49y to the power of 2. Alright, so again, we are dividing fractions, so you do keep, change, flip. That means you keep the first fraction, change the multiplication, then flip this. So you're multiplying by the reciprocal. So 49y squared over 81x to the 10. Alright, so now let's start simplifying this. So let's see what cancels out. Y squared, those just go away. 49 over 7 is just 7 over 1. Then we have 4 x's on top, 10 x's on the bottom. So these 4 x's cancel 4 x's here, so we're left with x to the 6. So this is what we have as of right now. We have 2 times 7, which is 14. We have 81x to the power of 6. Then let's see if 14 over 81 reduces. It should not reduce. Yeah, just say it's 14 over 81, so just leave it the way it is. 14 over 81 x to the 6. So the x to the 6 remains on the bottom. Again, you can always, right, so in doubt, just expand it out. So x to the 4 means you have 4 x's on top. X to the 10 means you have 10 x's on the bottom, so 4 of those cancel out 4 on the bottom, and you're left with 6 on the bottom. So that's how I got that. Alright, so now on 7, same thing, we have a negative exponent right here, so let's go ahead and flip this. Alright, so we have negative 243 over 32 to the power of 4 over 5. Again, there's different approaches you could take here. You could find something that has a power of 5 that gives you 243. Alright, so 243 is right here, 3 to the 5. 32, we can get it with 2 to the 5. Alright, but be careful, this has to be a negative. So we're going to have to use, it's going to have to be negative 3 to the power of 5 to the power of 4 over 5. And then on the bottom we got 2 to the 5. So your 5's cancel, and we get negative 3 to the 4 over 2 to the 4. Alright, negative 3 to the 4 would give you negative 81. Well, let's see what it actually gives us. Negative 3 to the 4 would actually give us positive 81. So let me change that. Should be positive 81. And then 2 to the 4 gives us 16. Alright, and that's our answer. Alright, another approach that you could take. Here, let me get a sticky note. So another approach you could take on this one is alright, let's say you have, so same question, negative 243 over 32. Alright, this is saying the fifth root to the power of 4. So I could take the fifth root of negative 243, raise it to the power of 4, and I could do on the bottom the fifth root of 32 to the power of 4. Alright, this is just another option you have, but you have to understand that you could do this also. You don't have to do it, but you have to understand it for the test. So math, I'll just keep doing that. So math 5, we want fifth root of negative 243. Right, that's negative 3. If I raise that to the power of 4, we get 81, which is what we had. Same thing on the bottom. If I do the fifth root of 32, we get 2. And if I raise that to the power of 4, we get 16. Which is the same answer we got here. Alright, so now let's look at 8. Alright, so on 8, first I'm going to do the power rule. Everything in here gets squared. So negative 2 squared would give you positive 4. X to the 6, z squared. And then we're multiplying it with negative 3x4, negative 5xy4, z cubed. Alright, this is just a product rule. Alright, the 4, negative 3, and the negative 5, you multiply that like normal. That would give you 60. X to the 6 times x to the 4 times x. So you add the exponents, would give you x to the 11. Then we have y4, that didn't multiply with anything. And then z squared times z cubed would be z5. Alright, now on 9. Here we have the power rule. Remember, the only time you multiply exponents is when you have them on top of each other. So exponent on top of another exponent, multiply those. We get y cubed over y5. Right, this would be a quotient rule, so you would do 3 minus 5, which would give you y to the negative 2. And then you don't want any negative exponent, so let's bring this down, make it 1 over y squared. And again, you could also think of it this way. You could think of it as having 3 y's on top, 5 y's on the bottom. These 3 y's cancel those. They cancel 3 on the bottom, so you're left with just this answer: 1 on top for y squared. So remember, there's different ways to approach this, different ways to think about it. Alright, so that's simplifying. Now let's go to solving. So solving, we have 343x equals 7. So when solving, you want to get the same base on both sides. So same base when solving. So on number 10, we got 7 cubed. Alright, so we're going to use base 7. So 343 can be replaced with 7 cubed. So this is 7 cubed to the power of x equals 7 to the power of 1. Alright. 3 times x, we got to multiply those. We get 7 to the 3x equals 7 to the 1. Once we're done simplifying, you're going to drop your bases. We get 3x equals 1, divide the 3, x equals a third. right, which makes sense. 1/3 is like cube rooting, so cube root that, you get 7. Right, now on 11. This 1/8, we want everything to be kind of even, so we're going to flip this back. So when I flip it back, we get 8 to the negative 1. Now let's choose a base to replace 128 and 8 with. There's different options. Let's see. Okay, let's see. This one might only have one option. So just 2's, 2 cubed and 2 to the 7. Alright, so we got 2 to the 7 to the x and 2 cubed to the negative 1. Alright, you're going to go ahead and multiply your exponents. This is a power rule. 2 to the 7x equals 2 to the negative 3. Your bases are all good. Your bases are all the same. Everything's all good. You simplified, so now drop your 2's. 7x equals negative 3. Divide the 7. X equals negative 3 over 7. Right, now for 12. Same thing. 8 and 16. 8 can be replaced with 2 cubed. 16 can be replaced with 2 to the 4. Alright, you have the same base. Now go ahead and multiply your 3 and your x. That makes it 2 to the power of 3x equals 2 to the power of 4. Alright, when you're done simplifying and have the same base, drop those same bases. 3x equals 4. Divide by 3. X equals 4/3. Same thing on this one. We're going to have to flip this 81. We get 81 to the negative 1 power of x. I'm going to go ahead and multiply these. Just knock it out right away. We have 81 to the negative x equals 729. Alright, so I flipped this, multiplied by negative 1 in the x, got negative x. Now let's get the same base on both sides. So 81 can be made with 9 squared. And 729 can be made with 9 cubed. And go ahead and multiply your exponents here. 2 to the negative, wait, that's an x, sorry, it should be negative x. So 2 to the negative x makes 9 to the negative 2x, and then 9 cubed. So once you're done simplifying this and you have the same base, go ahead and cross your bases out. We get negative 2x equals 3, divide negative 2. X equals negative 3/2. Alright, so make sure to study up on this also. Alright, so 9 through 16, this is still the same thing, solving for x. So your goal is to get the same base on both sides. 9 can be created with 9 squared. 27 with 9 cubed. Right, again, these are power rules. Guys, always be careful when you multiply these. So you're multiplying a binomial with a number. So this is 2 times x plus 2. This becomes 9 to the power of 2x plus 4. Right, so don't forget to multiply the 2 with this 2. Same thing on this side. 3 times x minus 1 makes 3x minus 3. Alright, so be careful with this multiplication. Now drop your 9's. Alright, let's get the x's on one side, the numbers on the other side. So I'm going to move my 2x just to keep the x positive. Alright, that goes away. I'm going to move this 3, so add 3. Alright, so we get 7 equals 1x, or x equals 7. Now on 18, it's kind of like the other ones. We have to flip this 1 over 25. We get 5 to the 3x equals 125 to the negative 1. 125 can be replaced with 5 to the 3. Alright, so I get that from my table of powers. Again, we got to multiply our 3 on our negative 1. We get 5 to the 3x equals 5 to the negative 3. Your bases drop. We get 3x equals negative 3. Therefore, x equals negative 1. Right, now for 16. We have 2 to the power of x plus 3 times 4 to the power of x minus 2. Right, this right now I can't multiply because they're not the same base. So let's go ahead and make everything the same base, even the 32. We got 2 to the x plus 3 times 2 squared to the x minus 2 equals 2 to the 5. Right, so we now have the same base, so let's go ahead and simplify this a little bit further. We got 2 to the power of x plus 3 times 2 to the power of 2x minus 4 equals 2 to the 5. And since these have the same base and we're multiplying, we go ahead and add these. So this becomes 2 to the power of 3x minus 1 so again I just added these. X plus 2x is 3x, 3 minus 4 makes negative 1. Now drop your bases, we get 3x minus 1 equals 5. And then add the 1, we get 6, divide by 3, x equals 2. Alright, so that's that one. Alright, so the next one is 17. We got 16 to the 3 over 4 divided by 16 to the 3 over 5. Alright, so let's see. Same base, we're dividing. So this one's a quotient rule, so we got to subtract the exponents. Alright, when you're subtracting fractions, you got to get the same denominator. So we got 3 to the 4 minus 3 to the 5. I can make the same denominator 20. So let's multiply this one by 5s, this one by 4s. Alright, so we got 15 over 20 minus 12 over 20, which makes 3 over 20. Alright, so your answer here is actually 16. I'll put it over here. 16 to the power of 3 over 20. Alright, so now for 20. Consider y equals 2 to the power of x plus 3. What is the equation of the asymptote? What is the y-intercept? So the asymptote, you can get it from the k value, y equals 3. So that's the horizontal asymptote. And now what is the y-intercept? So the y-intercept is when x is 0. So this is 2 to the power of 0, which is 1 plus 3, so 0, 4. And also you can get this all from the calculator. 2 to the power of x plus 3. Go to the table. When x is 0, we get 4, and then this is approaching 3. So this number that starts repeating is 3, so that confirms that's the asymptote. So again, all I did here was 2 to the power of 0 plus 3, which is 1 plus 3. Alright, so then 22, what change occurs when the function y equals 2.5, 5 to the power of x is changed to 2.5, 5 to the power of x plus 1. Alright, so the domain shouldn't change. It should always be negative infinity to infinity, or all real numbers. So a is gone. The range would only change if the graph shifted up or down, which this does not. It only goes left 1. So this didn't change. And then we have two options. Domain and range do not change. Domain and range are interchangeable. So let's just look at the two graphs. Alright, so the two graphs, again, the domain is always going to be the same, negative infinity to infinity. Right, the graph did shift left 1, but that doesn't affect the range. It didn't go up or down. So here the domain and range for both of those equations is actually still the same. Nothing changed. Right, they both still have domain of negative infinity to infinity, and range is still, for this case, 0 to infinity. Right, now for 23. The graph of the exponential function h is shown on the grid at right. For what values of y is h 0, or h of 0? Alright, so this isn't h of x, this is h of 0. So when x equals 0, what's the y? Alright, so when it's 0, the y value looks like it's 12. That's all you do on that one. When x is 0, 12. H of 0 equals 12. Right, and then for the back, this one's on graphing. Given the following transformations, write the equation, state the domain and range, and write the equation of the asymptote, then graph and include the asymptote on the graph. Right, use y equals 2 to the power of x as the parent function, reflection over the y-axis, translation down 4, translation left 3. Alright, so reflection over the y-axis, that means if we reflect over the y-axis, that means the base is 1 over the base, or 1 over b. The base is 2, so this is 1 over 2. If I want to go left 5, the exponent has to be x plus 5. If I want to go down 4, minus 4. Based off this equation, I know that the asymptote is going to be at negative 4. Alright, so once you know the asymptote, just put it on the graph. So 1, 2, 3, 4. The reason you want to put the asymptote first is because it kind of guides you when you make the graph. So let's get a couple points and let's graph this. So 1/2 to the power of x plus 5 minus 4. Let me go back to 0. Alright, so here we can see that we're approaching negative 4. Again, but it's not going to be exactly at negative 4, so let's see if we can find some other points we could use. Right, here's some. Right, we got negative 8, 4. We have negative 7, 0. We have negative 6, negative 2. We have negative 5, negative 3. And then we start getting really close to the asymptote. Alright, so this is going to be the function. Alright, so we get really close to the asymptote, but not exactly. And then just follow your points. Right, for the domain, that's not going to change. It's still going to be negative infinity to infinity. And then your range would be from negative 4 to infinity. And again, you're not using any brackets. We're just using parentheses. Alright, so that's the end. Well, not the end of the review. Here, let's talk about one more thing. So, one thing that's on here, if you have b to the power of x minus y, So this is in exponential form. In radical form, you would write this as the y root of x raised to the power, or here, not x, we're using base b. Alright, so the b raised to the power of x. So that's one way of writing it. Another option, you could also do the exponent first, then do the root. Either way, you get the same answer. So for example, let's say if I did, let's say 81 to the power of 3 over 4. Right, this is telling me to, or this is telling us to take the fourth root of 81 and then cube it. Alright, so we did some of this earlier. So math, alright, let's make this a 4 of 81, you get 3. Then if you cube the 3, you get 27. If you wanted to, you could also do the cube first, then do the fourth root second. You would still get the same answer. So let's see, 81 cubed is 531,441. And then take the fourth root of that. So the fourth root of 531,441 is 27, which is what we got. So either way, you would get the same answer. It doesn't matter what order you do it in. Alright, so let's do one more. Let's do 27 to the 2/3. So the 3 on the bottom is telling me to cube root to 27. The 2 is telling me to raise it, raise it to a power of 2. Alright, so cube root of 27, I'm sorry, math, 4, right, we get 3, if I square it, we get 9. Right, option 2, you could do 27 squared first and then do the root, you still get the same answer. 27 squared is 729. If I cube root this, and we get 9. Alright, so that's the end of the review. Just remember, there's different ways you could write this. This is exponential form. And this is radical form. Alright, so that's the end of the review. Make sure you study hard. Don't forget to like and subscribe.